Okay, today we are going to be factoring quadratics, but understanding if they're difference of perfect squares. Okay, here are your notes. Explain what is similar and what is different in the product below. How do we multiply the binomials? What is similar? They both have x's. And 3's, all right? That's what they both have. What is different is the signs. Okay, one's negative and one's positive. How do we multiply? Well, we can either, remember that we use the box method, or distributive property. Okay, so now a few ways that we've already learned how to factor. One way is when you're dealing with a binomial is to pull out the greatest common factor. Now we can do that with some of these, but what if you cannot? Okay, for this one, for this problem here, we do have a greatest common factor. However, for the second problem, we do not have a greatest common factor. So what is another way of factoring these binomials if they're factorable? One is by seeing if we have a difference of two perfect squares. So you got to ask yourself the first question, are both terms perfect squares? So that means, can we take the square root of 4x to the 6th and 16? And notice that we have a minus sign in the middle, so that is how we understand that if it's a difference of squares, difference meaning subtraction. Okay, so the square root of 4 is 2, and the square root of x to the 6th, since we have x to the 6th, we want to know what two terms when multiplied give us x to the 6th, but those two terms have to be the same. Now remember, we're going to have exponents. So according to MADS, when you multiply, you add the exponents. So those two variables raised to an exponent, those exponents have to be the same. So what two numbers are the same that add to 6? And that would be x to the 3rd and x to the 3rd, because 3 plus 3 is 6. So really what you can kind of see here is that if we take the exponent and divide it by 2, if we cut it in half, we get 3. So x to the 6th, the square root of that is x to the 3rd. And the square root of 16 is 4. So we know that we have perfect squares. Both terms are perfect squares. So then we can go ahead and create our double set of parentheses, one with a minus sign in the middle and one with a plus sign. It does not matter whether the plus sign is here and the minus sign is there. And then you're going to take the square root of both terms and place them in the parentheses in the correct position. The square root of 4x to the 6th is 2x to the 3rd. So it is the first position of the binomial. So it is the first position in each binomial parentheses. So 2x to the 3rd goes here and 2x to the 3rd goes here. The first term of each set of parentheses. The 4, which is the square root of 16, goes in the second position of each binomial, each set of parentheses. And there you have the factored form of the difference of two perfect squares. Pause the video and take a second. Try the check for understanding and turn the video back on and see if you are correct. Okay, so we have to factor the following. X squared minus 49. There's no GCF here, so we have to see if we have the difference of two perfect squares. We do have a minus sign, so is x squared and 49 perfect squares? The square root of x squared is x. The square root of 49 is 7, because 7 times 7 is 49. So yes, we have two perfect squares, so we can create our double set of parentheses. Plus sign, minus sign, again, doesn't matter where they are. Square root of x squared is x, that goes in the first position. And the square root of 49 is 7. Those go in the second position. And you have your factored form of our difference of two perfect squares, x squared minus 49.